So with that image now scarred into your eye, okay. So we're gonna start section 4.7. So section 4.5 was basically just graphing the four other trig functions. Okay. I remind you that tomorrow your graphs of cotangent and cosecant are due. Okay. One on each side, preferably. If you put them on the same side, just make sure you got plenty of room to show all of your work and how you found those key points and all that fun stuff too. Okay. And that is in everyone. Okay. That is an everyone homework, not just an 80%ers, but that's in everybody needs to turn that one into one. Okay. All right. So then we kind of combine, since 4.5 is so short and 4.7 is medium length, we kind of mesh them together into one, like. Now we're not going to finish this by next Wednesday, just so you know. So we'll pick this back up again, coming back after winter break. Yeah, we're already talking about winter break. Like just yesterday, I was still coaching volleyball, and now we're talking winter break. Okay? So we'll pick this back up after we come back from break, and then we'll give you a couple of days to review the final. Then second semester break, we go. Like that's when we get into this stuff. Like the fun stuff. But really, it's the fun stuff. Okay. But we need to get all this basic stuff in, or the building blocks. Okay. So 4.7 is all about inverses. So we're going to talk about the inverse trig function. But in order to do that, let's talk first about what an inverse is. You did some inverses in algebra 2. I don't think you did any in algebra 1. Okay? You use inverses all the time. Okay? If we're multiplying by something and you need to solve it, you divide. That's an inverse operation. Those are inverse operations. We're going to talk inverse functions. Okay? So the first thing that you do with an inverse function is, so you've got your function and you want to find the inverse. So the very first thing that you do is you switch x and y. Okay? That's the very first thing that you do is you switch x and y. You missed like 5 minutes of great Linsmeyer talk. Yeah. Okay? So that's the very first thing that you do. Switch them around. So that would be, so if my function is y equals 3 times x, that would become x equals 3 times y. Literally just switch the position. Substitute y in for x, substitute x in for y. Okay? And then what you do is you solve for y again. Okay? So we're going to solve for y. So in this case, that would be y equals x divided by 3. Now, when we do compositions of functions, okay, so if we had two different functions, so if I had f of g of x and g of f of x, if those are truly inverses, when I plug one in for the other one, I should get back, okay, we get x. X. That's just a function. Where it should be, yeah. Because you plug this in for x now, right? So you plug that in here, right in there, and you get 3 times that, and you just get x. That means it's truly a function, or truly inverse. Let's try another one. Walk me through it. Okay? Y equals x plus 7. Swap x and y. So what does that mean? What's it going to look like? X equals y plus 7. And then we do what? Subtract 7. So we get y equals x minus 7. Plug it back in. X minus 7 plus 7 is just x. Boom. Plug it in another way. X plus 7 minus 7. Let's kick it up a notch. Is it, I keep forgetting, is it Emeril Lagasse or is it Bobby Flay that on those cooking shows kicks it up a notch? Bam! Or is it, who's, Guy Fieri, from here, right? Maybe it's him, I don't remember who, but we're kicking it up a notch. Okay? Here we go. Enough with those linear functions. Oh my God, there's a quadratic. What do we do? Swap x and y. Same thing. Okay? Same thing. So we got x equals y squared. How am I going to solve that? Square root on the side, right? Okay. Now I'm solving, right? Solving and taking the square root. What I got? Plus or minus. Yeah. Because remember, y equals x squared. That's a parabola that opens up, right? Okay. If I just add positive square root of x, that's half of a parabola that opens to the right. If I have the negative one, it creates the other one. But now it just doesn't. Individually, they are each function. Together, it's not a function, but they're still. Like it not at all. Oklahoma. Exponential function. Now what? So switch x and y, right? So x equals 3 to the power of y. Love it. This one you might not have. You might not have this in your repertoire. Yeah, we can log. Switch to the log form. Yeah. So we get y here equals log base 3 of x. Love it. Ruh-roh. Now we got y equals sine of x. X equals sine of y. I'm just going to give you this one because it's what we're going to talk about today. Y here is equal to the inverse sine of x. Yeah. Love it. So let's talk about the inverse sine function. Okay? If I'm going to talk about the inverse sine function, first thing I'm going to really talk about is the sine function. Okay? So the graph of our sine function would be oops, that went too far. Kim? Oh, they didn't go far enough. Nope, that looks pretty good. Right? That's our sine function, yes? Okay. Some key points on here. Let's get a little horizontaling of our axes. So this would be negative pi over 2. This would be negative pi. This would be 0. That would be pi over 2. This would be pi. This would be 3 pi over 2. This would be 2 pi-ish somewhere right there. Yep. Right? Did a whole graphic. Okay. So let's look at some key points along the way. Like, for instance, 0, comma 0, right? Right? What about this one? 1, comma 0? No. Love it. Love it. Because remember, the x's go first. Yeah. Okay. What about, let's go over here. And so on and so forth, right? Okay. So if I want to find the inverse, I want to graph the inverse function. Flip around, right? We still flip the x and y, right? Okay. So let's do that. Let's go down here. Okay. So now here we go. The inverse function of that one. Actually, yeah. Let's do this. Let's do it. Yep. And yep. And yep. And and shabam. There's that one. And shabam. There's that one. Love it. So now my question to you is, the x-axis on my first one, let me scroll back up, this x-axis, because if I switch my x and my y, this x-axis becomes my y-axis, because wherever there's an x, I switch it out with y. So that x-axis becomes my y-axis. So up here, so this would be pi over 2. This would be pi. This would be 3 pi over 2. Negative pi over 2. Negative pi. Negative 3 pi over 2. Right? My y-axis, we forgot to label our y-axis up here, but you guys nailed it like it was, you dropped it like it was hot. We had 0, and we had there, we had 1, right? My y-axis now becomes my x-axis. Yeah. So then down here, I'm going to have negative 1, 0, and positive 1. Yeah. Okay. So we went through the point 0, comma 0, right, on our sine curve. That means we're going to go through the point 0, comma 0, because if you flip 0, we still get 0. Right? Okay. Then we went through the point, what was our next one? Way up top, let's see. Oh, I got to go all the way up. Then our next one was pi over 2, comma 1. So that point is going to become 1, comma pi over 2. So I'm going to go to there. Then my next one was 0, comma pi, right? So that's going to become, or excuse me, pi, comma 0 is what it was. I'm sorry, I already said it. It was pi, comma 0. It's going to become 0, comma pi. So that's right there. My next one then is 3 pi over 2, comma negative 1. That's going to become negative 1, comma 3 pi over 2. Going back the other way. This one over here is negative pi over 2, comma negative 1. So that means I'm going to go through the point negative 1, comma negative pi over 2. That's right there. Now, if you see this function, here it comes. Wow. We got to get it down a little bit more. Wow. Right? And so instead of it waving horizontally, now it's waving vertically. Okay? Now it's like a slinky. You ever just grab onto a slinky and just let it drop? Okay? Now it looks like that. Slinky. Okay? Love it. Okay? What's wrong with it though? Horizontal like that? No, vertical. Yeah. So that means what? Not a function. What be your function? Oh, my Lanta. Okay, well, let's talk first about notation. There's 2 different ways to write the inverse of sine. Okay? The first one is just what you've seen. You've seen it all along. And that is sine to the negative 1 of something. Now, if I have, my bad. Okay. If I have a regular sine function, what do I put in my regular sine function? What goes in a trig function? An angle, right? And what comes out? Just a number, right? Just a number. A number. Right? So now what goes into an inverse one? The number goes in, what comes out? The angle measure. Yeah. So inverses are used to find angles. Okay? Inverses are used to find angles. So that's the first one. You've seen it. You've probably used that one. I know for sure you used it back in when you were a tree in geometry, because they're doing that right now, where they're using SOHCAHTOA and they're using the inverses to find angles. You've done that this unit already in the first couple of sections of chapter 4. We did that, right? Love it. Good job. The next one, this new one, probably you don't know. Arc sine. Oh, yeah. Okay. Arc sine. So, if we're putting numbers into our inverse function and we're getting out an angle, we got to figure out where we can find our answers so that we can utilize that. Okay? So what I'm going to do here is I'm going to say we need all values between -1 and +1 of sine, right? So we need, what I'm saying there is, because remember sine right? The sign is in between there, +1. What I need on this graph. Now let me see if I can do this. There it is. See there? Shut my hand. Okay. So on that graph, we need all the values between -1 and +1. Right? So what's going to happen is I'm going to chop off part of it. Yes, we're going to chop the tree like we did the other night. That Mr. Miller came up with the chop the tree chant at Hockey. Okay, so I'm going to chop all of this off. All gone, all gone, all gone, all gone. All gone, all gone, all gone, all gone, all gone. Why can't that go there? Okay, so I'm just left with that. Okay. Now, do I have all of my values between -1 and +1? Yes. Yeah, because I go from -1 to +1, right? Okay. And so this is the function. Now it's a function, right? If I just say, nope, that I'm restricting my domains, that's inputs, right? I'm restricting my domains to between -1 and +1. I'm also restricting my range to go from -π/2 to +π/2. Now I've got a function. Okay? So this is the y equals inverse sine of x, or y equals arc sine of x function. Okay? Now, here is the big one. This will only, and we're going to underline only, give angles, because that's our output, right? In an inverse function, the output is angles. Okay? We're inputting a number, we're getting out an angle. This will only give angles between negative pi over 2 and positive pi over 2. So when you use the inverse sign, or when you use arc sine, your answer, your angle that you get out, has to be between negative pi over 2 and positive pi over 2. If it's outside of those values, you be wrong. Okay? Because it doesn't work, because we restricted our range to make it be a function. Okay? So what I'm saying, double star, is that the inverse sign and the arc sign only lives on the right half of the unit circle. Okay? Because if I pull up our unit circle here on the sideboard, okay, because negative pi over 2 is down here. Positive pi over 2 is up here. So we're only living, inverse sine, arc sine, only lives over here on the right half of the unit circle. Okay? Let's try something. Here we go. Okay? So the arc sine of 1/2. Okay? So in my brain, I'm thinking, where on the right side of the unit circle is sine equal to 1/2? Where on the right side, unit circle, sine is x or y? Sine is y. So where on the right half of the unit circle is my y value 1/2? Pi over 6. So the angle here is pi over 6. Because that's where on the right half of the unit circle is 1/2. Okay? It's not 5 pi over 6, because that's not on the right half of the unit circle. That's outside the values that I can get. Okay? Now, here's where your minds are going to get a little bit frazzled. Okay? Ready? Steady, go. Where on the right half of the unit circle is sine equal to negative 1/2? Pi over 6? 11 pi over 6? No. Why is it negative pi over 6 and not 11 pi over 6? So what do our values have to be in between? Negative 1/2 pi and positive 1/2 pi. 11 pi over 6, whoever said it over here, that's bigger than 1/2 pi. Okay? So that's you want here. You want to say 11 pi over 6. Okay? But my output has to be in that range. So the answer here is, instead of 11 pi over 6, it's negative You now give you guys a chance to try some. You try those 4. Stuff with TC. All right. So right side unit circle. Where are we? 3 square 3 over 2.
We are
5 over 3, isn't it? Yeah. Okay. I thought you said pi over 6 there for a second.
no, I said
Okay. Okay. Right. And this one we said was undefined, right? Because nowhere, or not possible even, I would accept that too. Because nowhere on the right side of the unit circle is sine equal to 2. Sine's got to be between 1 and -1. Okay? Right side unit circle, where is sine equal to 0? 0. Right side unit circle, where is sine equal to -1? Negative pi over 2. You want to say 3 pi over 2 there, but you got to say negative
So
pi
if
over 2.
it's inverse, it goes negative.
Mhm.
It's not the positive.
Yep.
Okay.
Yep. What's up, Snowy?
Wait.
You sure? What was that yours? That would be outside my range too. Yep. So what Smokey was saying is on number 5 here, could it be 2 pi? Because 0 and 2 pi are the same thing? Nope, outside our range. Talk to me.
Would it be possible to have like sine of -1/2 or no?
Sine?
Yeah.
Like regular sine or inverse sine?
Regular sine.
Regular sine of -1/2?
Yeah. Oh.
Yeah, because that's an input. Yeah, that's an angle. We can have an angle measure of -1/2 radians. It just won't be on the unit circle. I mean, it's on the unit circle, but we just haven't defined it. You know what I mean? Yeah. Okay?